Okay, let's start. Can everybody hear me well? Okay, that's correct, because there will not be slides. Okay. Edskar Wiebe Dijkstra was a pretty remarkable man. He was born in 1930 and he died in 2002. And he was educated a theoretical physicist, a deeply disciplined man. He started in the late 50s to work for something called the CWI in Amsterdam, which is a mathematical institution. And even though he was educated as a theoretical physicist, with his mathematical inclination, he was the right person to develop the first software there for the first computers. This was a very different time. He developed software at the moment that the computers themselves were being developed. So there was an interface between the hardware and the software, and he was developing software at the moment that he did not have a physical machine to test his software on. He is famous for working on Algol 68. And he's also famous for the statement code 2 considered harmful. And he's also famous for inventing something called structural programming. Dijkstra was convinced by his boss that a new science of computing was required, and that science at that moment was not there. And he struggled with this because he was quite an arrogant and intellectually inclined person. So he wanted status, and as a theoretical physicist, he probably would have had it. And he was not directly inclined to form a completely new field in that sense. But he was convinced with this by his boss to do it. And with that he sort of bootstrapped in the Netherlands computing science as we know it. At some point he got married, and in the Netherlands it is required on your marriage certificate to state your profession. He is officially the first programmer in the Netherlands, and it was a huge fight with the authorities because programmer was not in the list of possible professions, and this was what he became. So here we have the first Dutch programmer. One of the things which is remarkable about Edskar Wiebe Dijkstra is that in this time it was not possible to communicate very easily. He wrote down all his thoughts every evening on paper, by hand or by physical typewriter. And they are called the EWDs, Edskar Wiebe Dijkstra, and they are numbered. And they run into approximately 1,500 of them. And it's a remarkable amount of information and knowledge which he wrote down. And I can still recommend to watch those, or not watch those, but read those papers. One of the things he was really remarkable about is he was so deeply disciplined in writing versus talking that he spoke very slowly. He sort of first had the thoughts in his head, and only after he formed the thoughts in his head, only then he spoke about it. In 2001 I was lucky enough to work with a colleague who was a student of Dijkstra. This was also quite an arrogant and intellectually inclined person, and he was studying at the university in Eindhoven, Technical University. And the Technical University was a little bit going down in status, mostly because Edskar Wiebe Dijkstra, who used to be a professor there, just left for the States, and he moved to Houston. And this colleague of mine, he's called Ron Kersik, told me a story about how he applied at Dijkstra to be his student. Just imagine, we have a 20-year-old person quite arrogant, wanting to up the level and become the student of Dijkstra, who was in Houston at that time. So he wrote him a letter, whether he was allowed to be his student, and Dijkstra said, yeah, sure, just come over and we'll have an application and we'll see if you can be my student. So Dijkstra, Ron Keswick, very nervous. He flew to Houston. This was the time that you could still smoke in airplanes. It's different time. And took a hotel very close to the place where Dijkstra was having his office. And in the morning, Ron went to his office and was asked to wait outside on a chair until Dijkstra came in. Dijkstra came in, took Ron Keswick to the whiteboard and asked him to write the letters of the alphabet. And Ron wrote as beautiful as possible all the different letters of the alphabet, after which Dijkstra also went to the whiteboard and said, yeah, it's pretty okay, but this R a little bit different, and this H, I cannot directly see it, and the I is difficult also, because perhaps it's a 1 or perhaps it's an I. Now, Mr. Keswick, if you go to your hotel, then next morning we will try it again. Practice very hard on the letters of the alphabet, and then the next morning when you can come in, we'll see if you can become my student. So Ron went to his hotel. The next morning, completely nervous, he went back to Dijkstra and was asked again to write the letters of the alphabet on the blackboard. And Dijkstra said, well, good progress, you're allowed to be my student. And Ron told me this story at the moment that we were sitting in a bar in America, because we needed to work there at that time. And we had both a little bit to drink, and I asked him, did you study in the evening? And Ron's post said, yes, the whole evening I studied on writing the letters of the alphabet as Dijkstra would have liked it. It's just an example of how disciplined this man was. Dijkstra is also known for the Turing Award lecture in 1972, in which he most focused on that programming is a branch of mathematics. And Dijkstra, arrogant as he was, thought actually that the not so good mathematicians would probably be better to not become programmers, because programming would be the hard part of mathematics. Dijkstra also missed a couple of things. So, for example, Carl Hewitt, who we know from the actor model, later conveyed the information that Dijkstra missed, that the assignment operator was actually a more harmful thing than the go-to statement. In that lecture in 1972, he rephrased something which he said before in 1968, which was a phrase called the software crisis, in which he posited that the main challenge, the central challenge of programming is how to maintain intellectual control over the complexities of our own makings. In other words, how to not make a mess of it. I posit that that challenge up this moment has still not been met. I want to have a short question. So I'm curious about the age distribution in the audience. Who here is younger than 20? Who's older than 20? 25? Older than 30? 35? 40? 45? 50? 55? And there we go. I'm sorry. My apologies. I try to see everybody at the same time, and that's not easy for me. I was born in a small town in Gouda in the Netherlands in 1971. The Netherlands is pretty much a Calvinistic culture, which for those of you who do not know it, we actually derive pleasure by disallowing ourselves pleasure. Not very well known. In general, I didn't talk much for the first 2 decades of my life. If you're born in 1971 and you grow up during the 80s as a child, being a nerd, it was just not a group yet, so nerds were sort of unpopular in that time. And up to the age of something like 12, I, at elementary school, was bullied. I was this type of person who open-eyed looked at the group at the moment that everybody was looking at me. That sort of made me very anxious, because most of the time that would mean that something would happen to me. In that case, I can see all of you and all your eyes at this moment as something which makes me incredibly uncomfortable. So I learned to distrust groups and distrust attention. And there are 2 points, 2 things which really stick to mind in that case. One time I observed that a bully opened up a sandwich of mine, spit on it, and then closed it and put it back. And even though I saw that, I still ate the sandwich. In another situation, I remember that I was kicked in the butt quite often, and at some point there was a group and they decided that I needed to be kicked in the butt, and they told me that I needed to turn around, and at that moment they could kick me in the butt. And I turned around so that they could kick me in the butt. And this gave me a long-term obsession. A long-term obsession with what is human action and what precisely is it that you make yourself act against your own interest. I basically started to distrust groups. Individuals sometimes are okay unless they are part of a group. And in all honesty, what I'm telling you is that I don't like you very much as a group. At 12, I learned to program. My father, he worked in administration, and at some time, the Chamber of Commerce, they showed what the future would look like with computers. So he went to a location where they showed him a computer, and my father thought, well, I'm 40, probably nothing will happen with me with computers anymore, but for my son, this nerd, let's buy him a computer. So he bought me a Commodore 64, which at that time was a month's salary for a 1 megahertz processor, 64 kilobytes of RAM, and it was attached to an analog TV. At school where I was, if children were being punished, they were given long divisions, because it takes a lot of time without a computer to calculate a long division. So I wrote a program which printed out the calculation of a long division, and with that, for the first time, I was able to earn a little bit of money from my schoolmates when they were being forced to do the long division. Then at age 16, by that time I had an IBM 286, a hard drive of 20 megabytes. I wrote a very small administrative program in Visual Basic for the company of my father. And for it I was paid, for 1 week of work, I was paid 2 times my father's monthly salary. I remember I told him proudly, and I can still see the short flash of jealousy in his eyes. In the end, I ended up going to the university in Delft, where I studied electrical engineering. At the age of 25, I was quite late. And there I learned to fight complexity with mathematics. Electrical engineering is very good for that. It's a character building education in that sense. It's applied physics. I don't know, just a small question. Has anybody worked with electronics? Okay. So, for example, there's something called the 7400 IC range, which basically are very small components, which are ANDs, ORs, XORs, and just the quality of those physical components, the quality with which you can mix and match them and still be certain that the totality of your composition works. It's quite remarkable. I also challenge you to, for one time, just look up the documentation of those small components. Most of the time, it's something like 15 pages, all types of environmental and environmental constraints. In that documentation, you can look up precisely what is needed to make a larger composition of those small components. And I've never seen any of that quality in what we are doing here as a programmer. Such a 15-page documentation for a simple component of just an AND or an NAND or an XOR, I would compare it with, for example, the fold method or the bind method. And we would not see things like the complexity, the guarantees, all those type of information. We basically are still in the process of understanding what we are doing there. Basically nowhere in computer science, and over the last 25 years, I've seen that quality being matched. I have an electrical engineering friend who started to work in France for a very small electrical engineering company, and his customers are 3 companies. They are Intel, Philips and Samsung. And what they produce is an image of what you can call a silicon corner. At the moment that you go higher in frequency towards the gigahertz, electrons just don't want to go around a corner anymore, but they bounce back. So the sole product is this corner with a little bit of quantum mechanical offsets in such a way that an electrical wave is being helped around the corner. Sometimes when I'm programming, I'm thinking about all those electrons which are just screaming around corners in a physical sense. The main property of the success of that company, and it exists already for 20 years, is focus on the smallest problem of your abstract composition and make that work incredibly well. I majored in chip design. Chip design is something which compiles a hardware description of a system of code into images. And those images are then projected onto silicon. In essence, it's a compiler. You take code and you put out an image. I got interested in compilers and interested in software that creates software. And the term software originally originated as a joke. We had hardware and we wrote all this code and we had no idea what software was. So they made the word software as a joke because nobody knew it. Nowadays software is a very normal word and everybody uses it. I still want to posit that we actually do not understand what software is. And that's a problem because software is eating the world. Human individual understanding is finite. We have a tower of layered abstractions on physics which yield software at the top, and it's just too large to fit in one head. Everybody goes up in the stack and at some point accepts an abstraction at a certain layer without actually being able to understand what goes underneath. And that's also a problem because with that we are living in our abstractions and we start to take them for real. I posit that nobody understands what we are doing when we create software. Really nobody. For the last 35 years, I've spent all my life on understanding what software is. There's literally nothing more important for me than understanding what software is. No relations, no family, no health, no status. I really don't care so much about it. I do not claim any authority, but I do claim the authority to choose my own authorities. And I would suggest that you do claim that yourself also. In that sense, I have nothing to give and nothing to gain other than repeating your understanding. The best authorities that I knew for understanding what computation was is Turing and Church, the untyped lambda calculus, which is my best model to understand software. And in the end, it all comes down to three constructs. Abstraction, which is pulling something known out of something unknown. Introduction, which attaches a name to that something. And application, which is applying something known to a composition of abstractions, which in the end is unknown. I like abstraction very much. Introduction, I'm already a little bit scared about. Where is this name coming from all of a sudden? What is this X? What is this name that we apply to it, attach to it? And the thing that I really despise is application. Because as soon as you apply something, you make it useful, and I distrust useful applications. So, where are we now in the realm of software? Are we maintaining, as Dijkstra posed, intellectual control over the complexities of our making? Do we make it for the better in that sense? No. We have millions of developers in the industry allowing bug-ridden shitty code into production. We are creating a world in which we are surrounded by machines that scream for our attention. We pay for that world by giving up our autonomy, our privacy, our intimacy, and our humanity. And we already crossed the threshold. I believe it is already too late to clean up the mess that we are ourselves responsible for in the last 40, 50 years. In that sense, I have no solution here. I'm not going to say how it's going to be better. But I would like to end with a couple of unpopular opinions, which probably are unpopular, especially in an environment like this. The first one is, software development doesn't scale in human effort. If you do need 2 teams to create one composition of software, you're doing it wrong. The second part is, let's start treating software contributors as part of the problem instead of part of the solution. And the third is, premature application is the root of all evil. I thank you for your attention. Are there any questions? Please.
Thank you for speech. What do you think about modern AI and machine learning from philosophical perspective?
I think that in modern machine learning we still have no idea what we're doing. In the end it is just prune and graph. And at the moment that we find new structures in big data, personally I have a dislike of it, because for me that means little meaning. Like small data can convey a lot of meaning, but as soon as we have big data, we only get little meaning out of it. The thing I distrust the most about it is the fact that it is not 100% deterministic for 100% of the input. And that in a broader social sense always makes that percentages will fall out of what is intended. And how to handle those percentages, I'm very worried about.
Yeah, so thank you for the talk. It's a very interesting subject, which is also, I don't know, it somehow resonates with my feelings. I missed the beginning, maybe you already touched it, but in the unpopular opinions, you said that it's already too late to clean up the mess. Can you elaborate maybe what exactly are your fears? What is the mess? Why we like, I don't know, my use when we used to program in, I don't know, Visual Fox Pro was also pretty messy, but we don't see this mess around. Maybe some mess cleans itself.
That's a positive view, and I like that positive view. My favorite abstraction is one vertical line. And then we have a left side and we have a right side. If this vertical line is a compiler, and I myself at this moment are on the left side of this vertical line, then putting this code through the compiler makes it applicable. I think that if we're looking at software development in the largest sense, with the millions of developers who are pushing code through that compiler to get on the other side so that it can be applied, I think that's the mess we're in. So just that code and that complexity which we cannot manage intellectually anymore, individually but also not as a group. And I think that all our efforts, if I would put a positive note, would actually be put the effort in to let code not go through that compiler. And in that sense, I hope I will grow old enough to, for example, see the technologies like independent types, IDRIS, ACDA, the certainty types, which allow it when you go through a compiler to the other side to be certain what is happening on the other side. Not certain if this is answering your question, but those are the associations which it evoked.
I have one note, or maybe what is your opinion? Because like, I have one hope in the software with the bugs, because I am way more afraid of like malicious use of software, like the social score in China or so. And if there are bugs and if there are hackers, maybe we can still get around it. So what is your opinion? Like, are the bugs or the software which does not work properly more dangerous, or like the malicious use of software?
Personally, I only see one solution, and that is just not participating in what the world is giving us in features. So for example, I myself, I do not have a mobile telephone. I do not have an alarm clock. Those kind of things which sort of draw your attention into it. Other than that, I just share your opinions about the worries that we have at this moment.
In what moment you became so disappointed in software development?
At some point there was a very good talk by somebody called Heather Miller about the buzz factor of all the libraries out there and how worrisome that is because of our dependency of human effort to actually maintain that. And the direction was that there should be more people who are maintaining the libraries. I turned in my head that idea around and took it serious, that perhaps we're working with something which is so complex that it is really true that only a very small group of 1, 2, perhaps 3 people can actually maintain a library. So that the idea of attaching more contributors to it is actually something which is negative instead of positive. This is something about, I think now 2.5 years ago. And that was the talk which at least made me also wanting to express my feelings, other than just go with the flow and be the happy-tappy programmer.
Hey, yeah, so I have two questions actually, or maybe not really question, more observation that I would like you to react to. So the first one is, you were talking about when you were young and you discover programming, and how you used that as a way to escape the bullies at your school, I guess, or the humans that were failing you, and how now you're considering that computers are failing us in a sense that we're losing of our humanity because of them. And the second one is, so you were answering that question about, I don't remember, but you said that you were looking forward for things like Idris that would give us more certainty on what we're doing with programming. But the same way, Idris and independent types are non-decidable, and it's a non-fact. And also, we know that we can't really guarantee what Idris is doing just because of Gödel theorem. So, what would be your take on that?
First, I offer no solutions for your second answer, because I don't have it. But if I would search for it, I would search for it in that direction. I can appreciate somebody like Conor McBride incredibly much, who is more or less the driving force at this moment of everything new which is happening into Haskell. But I would search for it for compilers stopping software instead of allowing software. Your first question, thank you for the first question, I appreciate that. I do not want to take away anybody's pleasure, which I know myself very much, of how programming on your own behind a computer can really create a bubble in which you are allowed yourself to flow. And in a sense, I do think that that is something which actually is very good. Also at this point I would like to state that even though this is a very negative talk, I'm incredibly in debt to, for example, people like Martin Odersky, who created the tools for me to escape that type of feeling, and basically also provided me with the tools to provide for an income, for my family, for myself. I think very often that is underappreciated, and the fact that we depend on these other people to give us the tools, and then we accept those tools sort of automatically as already being there, and we start to say negative things about the things which disappoint us about that tools. In that sense, I can be a pretty happy person in my own bubble, as long as it is not applied.
Thank you very much for that, Marco. You mentioned a distrust of groups, and I don't know if you've been following news from the UK in the last weeks and months, but there's a nation where I'm from which has been unable to come to a coherent decision. More recently, a parliament of 650 people who have failed to come to almost any decision at all. Is this evidence of the same phenomenon that you see as problematic for software? And is it a failure of the group to find a stable equilibrium, or are they finding a stable equilibrium but one that is far from optimal?
I'm looking at that. I'm following it. Thank you for your question. I'm looking at that more as an evolutionary process in which power is constantly either pushed down to smaller groups or pushed up to larger groups. I completely agree with the fact that it is a failure to reach a stable equilibrium. Historically, I would like to suggest that perhaps the age distribution in especially England makes that, coming from a background in which the UK was an empire, still tries to maintain that feeling of being an empire. When it comes to the decision itself, I would like to have had a vote in the UK first for England to leave the UK, and only after that we can decide whether England can leave the AU. But I say this a little bit with my horny, I'm also human, like, ooh, that would be good for them to experience that first, that going through that feeling. People are so sloppy with each other. Conor McBride, who I follow also on Twitter already 1.5 years ago, said the Irish border is going to be the breaking point. Nobody paid attention at that moment. And you could just wait up to the moment that very slowly that was going to be more or less the breaking point. Trying to answer your question, coming from the Netherlands, we are very much used to push power down to the lowest group, which is able to responsibly handle that power. And only when they prove not to be able to handle that power, then we try to push the power up. I think that in the AU, we a little bit too easily accepted the power at a higher level, and now we're in the dynamics of how that goes out. The last association which it evokes is that I remember that 15 years ago there was a referendum in the AU for the European Constitution. Around that time I was quite young and I chose to be against it. And I remember very clearly how there were politicians going from different countries to try to convince the people to vote for. And one of them was Brandt from Germany. And the sentence which he used was that just keep in mind that you guys are the first generation of Germans and France and England and Germany, when they see each other, don't start to shoot at each other. That didn't convince me at that time, and now I'm a little bit older, it convinced me now. I think we have a lot to lose by allowing or trying not to convince England to remain in the AU. And a personal opinion would be, I think there should be a next referendum, and I would hope very much that they will remain in the AU. I hope this answers your question.
First of all, thank you for your talk, for the personal story, and it was very interesting. You mentioned the barrier that the vertical line that the compiler sort of creates, and you said that you would like more code to stay before that line. Do you think the software that we have right now is beyond saving because people don't, maybe it's not just the compiler that allows too much to go through that barrier, but maybe people just don't spend enough time thinking about what they should put on the other side. Maybe we just rush too much with decisions, and once the code is on the other side, there is no way to bring it back and replace it with something better.
Yeah, I find it very interesting that in general programmers do not care very much about the actual human applications of the software they write. In general, we like so much the code that any problem that is given to us, we will try to solve it as the problem is stated, while we could think much more about what problems we are actually trying to solve. Just for a question, who here is writing software for, let's say, which helps the environment? Who here is writing software? Okay. Indirectly, yeah, okay, as a library writer, probably. Good point, very good point. I agree with that part, yeah. Yeah.
As soon as society starts paying us to write the software which saves the environment, we will be doing it. We just will be paid.
Yeah, but you are society. Yeah, but I agree, but just using the word we there already makes me a little bit uncomfortable. Because it separates us from society.
Like the same, any other group like bakers bake food which has a lot of calories because they're paid for it. So we do the same every other group does.
Yeah, but just because everybody jumps off a cliff doesn't mean that I need to jump off a cliff. Is that the opinion of we, or is that the opinion of you?
I think that's the way it was working now.
And that's a very good point. And I agree with that point. Yeah. Please.
You kind of talked very negative about what most of us do as a profession, and or yet criticism, let's put it this way. And then you kind of said in some answer that you are very gracious to Scala, and that's kind of what pays your bills. So you do software development yourself as a job, and how can you deal with the combination of doing that and what you said right now? Thank you.
I have a confession to make. So even though I don't state it out loud when I'm hired, my main goal is to not get software in production. And I warrant that for myself by knowing that there will be a force on the other side which is strong enough to balance me out and put software in production. But I would like it if there was more on my side, so that it is really more balanced. But thank you for your remark. Ruslan.
Question is why you think that mess is a mess? Because we have biological evolution which a very weak directed brute force. We have technology evolution, which is also a brute force, but directed less weak, more strongly. We have development of typed systems, which are, or maybe developed on Idris, which also brute forces, but very strong directed. Yes, so we have equation when on the one side is brute force, which we do, and the other side is is also power, is also brute force not to do of the second level, not to do brute force of the first level. Yes, and why you think that exists some optimal, or maybe that you need be on the one part where level of physical brute force is minimal?
I was not completely able to follow your question, but I don't think in black and white in the terms that one side can be good. I think very much that both always exist, and if I'm looking for a balance, then I'm looking for a balance of both black and white existing at the same time. I thank you again.
One more question.
Oh, sorry.
May I? Okay. About society and what it paid for us. Society pay us for result, not for software.
Sorry, society pays us for?
Us for a result, not for software. What is software? we can see as developers. As for me, it's a good software. It's like a good story. Scala is a good software. That's why we are here. But society doesn't care. Good story or bad story. They need just result. Plane flying, car rides, everything works. That's all.
I'm looking forward to your presentation on that subject.